they immediately launch tests to run back, all the time. So whenever on the 24-hour in a day, when somebody has updated and committed some code, it instantly goes into testing and comes back. And they get very quick feedback on what's broken, what isn't, even between developers. Developers like to work on their own, but once they commit the code, of course, others will see that others may suffer from it if it has effects, more broader effects in the product. And by getting that feedback immediately, you avoid that huge deluge that we otherwise have at the end of the release cycle, where suddenly you must do all the integration testing and everything breaks and everybody's crying and nobody knows how to fix it, and then sort of the oldest of the oldest architects must come in and figure out what went wrong. So you need to validate sooner and keep validating all the time, because today the cost of spinning up a test is much, much lower. But the cost of a human being doing unnecessary work is much, much higher. You must commoditize the building blocks. As techies, we always would love to have the most advanced servers and network gear and everything. We like to have the best piece of everything. But if we are really honest with ourselves, we should commoditize the underlying infrastructure, use cheap servers, cheap hardware, cheap networking, let it fail and replace it with something else. Because when we run on inexpensive infrastructure, it's less expensive when we fail. This is why some people today talk about servers not being pets anymore, but being cattle. Because in a cloud environment, if you have 10 servers orchestrated by a cloud, like Eucalyptus or OpenStack or CloudStack or whatever, you have 10 servers there. One server goes down, what do? You do nothing. You just redeploy the same workload on the next server. And maybe next week or on Monday you take care of the broken server. But this means, as a customer, if you were used to buying the most expensive top-of-the-line server from your server vendor and getting 24/7 support for it, you don't need it anymore. You can still buy top-of-the-line high-density servers because they may actually be more efficient. But you don't need 24-hour support for it, because if they break at nighttime or over the weekend, you just leave them. And then you go in the next week and take out those that don't work and replace what needs to be replaced. And the cloud, because it's designed for failure, it knows that the underlying infrastructure can give up at any point, and it has mechanisms for dealing with it. Then number 7, of course, I've believed in open source software for more than a decade, so I wouldn't stand here without saying use more open source software. That reduces the cost of failure for many reasons. Not just because you can use it without paying, but because open source software is open. So when something breaks, you can go in and see what broke. It gives you the power over the entire environment. That is why open source produces better code over time, more secure code with fewer vulnerabilities over time. Number 8, also distribute decision making. If you have a software project with 5 people or 10 people or 500 people, you tend to have decision-making cycles that escalate up the hierarchy and down. They take time. I'm a CEO myself, so some things get escalated to me. Every time when they get escalated to me, I think, oh darn, now I'm the bottleneck again. Because my colleagues send me an email and I'm lazy, I don't respond immediately, and then when I respond I'm offline and I read it and I wonder, I have a follow-up question. It takes them 3 days to get a simple decision from me. If I had delegated decision making to them, they would have made the mistake already that I was bound to make as myself, and they would be on to the next thing. So that also reduces cycle times, reduces the cost of failure. It has the additional effect that when you delegate authority to people, they actually step up and take more responsibility. And believe it or not, this whole thing was invented by the Catholic Church 1,000 years ago, or something called the subsidiarity principle. Put the decision-making in as subsidiary place as possible, as close to the action as possible. That's the best way to organize decision-making. And it makes you move faster. It makes you make more mistakes, but innovation is about making mistakes. So we are not here to reduce the number of mistakes, we are here to reduce the cost of a mistake. And that's why making the mistakes so small that we can quickly correct. And then number 9, have a culture that doesn't punish honest failure. That's difficult, because sometimes when somebody fails, you would like to say, darn, I could have done it better than you. Or why didn't I do this? Or why did you do that? Or why did you fail? But we must remember that when people are asked to be innovative and creative, this is just not just software development, but generally, you have to give them the right to fail, even when you know the right answer. That's a difficult thing for a manager to remember, that sometimes you must let the team make mistakes that you obviously can see happen. Because they make them once and then they stop making them. If you're always there telling them not to do that, you again use a slower decision-making mechanism, and you are not breeding this right culture of taking responsibility. So when you do all of this, you lower the cost of failure, and people start doing things. They're not afraid of doing things, they test things, and when they launch some software to test it, and it spins out on 1,000 instances and eats up all the resources, you could quickly kill that. It doesn't cost you $1 million to do such a test. And something has been learned, something has been gained, and the next day they come up with an amazing innovation, and they quickly test it, and they quickly ship it, and they do an A/B testing, and there you sit with a new feature faster than your competitors. And whether you are in a company with competitors or in a non-profit or government organization, you always compete against something. Maybe not another organization, but you compete for the attention of your users or your consumers. You have something you compete for, and with fast innovation cycles, you can serve them and you can be more successful. So I think it actually is this easy. This is what the new era allows us to do with cloud technologies, with commoditized hardware, with the new types of software we have. We can reduce the cost of failure and thereby get more innovation. So Adrian Cockcroft, cloud architect at Netflix, he tweets amazing things, so I can't help but quote him here. But he said just yesterday, in short, everyone needs to get on top of agile, continuous delivery, DevOps in order to compete. Agile, that was for shortening the batch size and the cycles. Continuous delivery is for testing sooner. And DevOps is another topic I'll come back to, the art and act of not separating the design of software and the deployment of software, but making sure that those who design and develop the software think about the operations, and that those who operate the software think about how it's being designed and developed. A funny term, DevOps, in my observation, I go to Eucalyptus users and customers and say, are you a DevOps team? And the teams that, in my observation, are most DevOpsy are the ones who say they aren't. So to me, I think it shows that somebody from the outside invented the DevOps term. But those who actually do it, they don't call it DevOps. It's a term used by others about those who do DevOps. Maybe you disagree, and if so, let me know. But I've been trying to wrap my mind around DevOps because I never hear people who are deep into DevOps call it DevOps. So I'm wondering why that is. Let me skip here a few slides. So here's just an example of what it is like today. You all know Eclipse. You can go into Eclipse and establish your own product, software development project and get going, and within a week you are up and running. Go to Envy, a startup with people in Ukraine or Romania and here. They let you start your project in 100 seconds. It's an online, cloud-based software development framework. You go there and you code better instantly. They allow you to get going immediately. And now we can sit there saying, who cares? If a software development project takes 3 months, who cares whether it takes 100 seconds to start it or 2 days? I mean, what's the big deal? Well, actually, it is a big deal. Because it turns out that the best software developers are also the most impatient ones. So if you can let them get going quickly, you capture the best ones and you keep them motivated and keep them on task. And also, if you suddenly have some idea and you want to quickly try it out, you don't want to wait 2 days for your environment to spin up. After 2 days, you don't remember what your idea was. So the immediacy of software development has a very real impact on our productivity. It's about giving instant gratification to software developers. And you know what the problem with instant gratification is? It comes too late. That's a joke. But it just means that you have to be, every second you can shave off that startup time helps you capture the creative mind. And you suddenly have this lightning in your head and say, I must try this out. If you can do it immediately, you can innovate much more. Again, Adrian Cockcroft, he came up with this monster acronym, but it's pretty good. Mean time between idea and making stuff happen. That's agility. How fast can you get going when you have an idea? Agility is also the opposite. How quickly can you stop doing something when the idea was stupid? That's probably the biggest waste we have in companies. Not that it takes time to start projects, but that it takes time to kill the bad ones. But the faster you can make these changes, the more agile you are, you lower the cost of failure, and you are more innovative. Of course, let's be clear here. Not all innovations can come in a nanosecond. There are some very difficult mathematical challenges that you have to think about for months before you can solve them. So I'm not saying that it doesn't exist. I'm just saying that there also always is stuff that will be very well served by an immediate environment that gives you immediate access when you feel like it, and then takes it away when you don't need it. So here's NSN, big telecom equipment manufacturer with 12,000 engineers. They used to do 4 tests of their LTE equipment, the equipment that gives you the broadband cell signal with many operators. They used to test it 4 times a month as they were developing it. Now they test it 4,500 times a month because they have an internal Eucalyptus cloud where they run it. And they run over 1 million instance hours per month on their cloud. So there's a lot of activity, and most of them are shorter than 30 minutes. It's a very quick cycle. Somebody goes up, spins up 10 machines, 100 machines, tests something, and is out of there, and the next one can start. The server utilization has gone from a little bit of 20% to 80%, so they're saving 75% of new hardware purchases. They are purchasing a lot of new hardware because the usage of the cloud is growing, but without it they would buy 4 times as much. Plurify, a company that allows you to speed up semiconductor chip design by emulating the testing on both public and private cloud. AppDynamics, one of the fastest growing startups in the Bay Area. They run all their test and development on a local private Eucalyptus cloud and all their production on Amazon. And as I mentioned earlier, because we have the same API as Amazon, they can move the workloads back and forth. So they get the immediacy of a private cloud as they are testing, and there's no extra cost of running a test. But then when they run full production, they go to Amazon where they get unlimited scale. Because the challenge with a private cloud is it's never unlimited. The benefit with a public cloud, it is unlimited, but then also the cost of it can become unlimited. So that was innovation. And then quickly, in just a few minutes, because I promised you to stop by 7:10, didn't I? What is it then, if this was how you make innovation happen faster, what's changing in software design? And now I really hope there are no experts in the room, because I don't develop software anymore, so I'm making completely wrong. But I'm sharing my observations with you and what I hear from really smart guys meaning men and women who develop software, and I'm learning from them. And I think I'm seeing a trend that there are 3 things that are very important today that weren't always that important. Applications need to be flexible, they need to be resilient, and they need to be user-friendly. We've always said that applications needed to be flexible, but flexible today means runs on any form factor, can scale to large size or small size, can rapidly be modified and changed and added, and that wasn't really the case even just 10 years ago. We built fairly static applications, and then when our website grew 2 orders of magnitude, we had to throw out everything and redesign it. Today it's possible to build more flexible applications than we're doing. The second is they must be resilient. And previously we assumed that hardware is resilient and software fails. But now software increasingly is being built to be resilient in its own right. So the software will realize if an instance is disappearing underneath and it spins up another one. It will do auto-scaling, adding nodes, removing nodes. And it will figure out the way to keep everything going even when you lose connectivity somewhere. Even if you lose access to the database for a moment, it's caching something so it has the data there. This wasn't the case 10 years ago. It was the case for the large leading websites, the Facebooks and Googles. They have been doing this for a long time, but generally in companies we didn't have that. And then the user friendliness, where again, those of us who were there, in the 80s, only a client server. You remember what it looked like when we called it user-friendly? It was so ugly. It was so complex. It was so rigid. And today, we don't have a single developer that isn't using a smartphone all the time, using iPhones and iPads and getting used to very intuitive, user-friendly user interfaces where you never have to read the manual. We used to laugh at those who didn't read the manual, but it has already changed. It's those who don't read the manual who laugh at us who read it. So the user friendliness has come to a completely new level and a new requirement. And if you want to win in something, if you have a consumer-facing application, or if you are IRS and you have a taxation application, consumers will not like your application if it isn't user-friendly in the way they are used to seeing in their smartphones, in their cars, on their microwaves, or wherever they have a user interface today. So this raises the bar considerably. So how do you make them more flexible? I think you rely on frameworks. So you code less and you use frameworks to give you the services you need. And you rely on APIs. 10 years ago, we all talked about source code. It was all about Linux, Apache, MySQL, PHP, Perl, Python, open source code. That still is very valid. But today we talk about APIs as well. And the new level of openness happens in APIs. Back then, an application was LAMP. Linux, Apache, MySQL, and PHP. One of each. Today, any website out there has 3 or 4 different database engines. There's a little bit of Hadoop and Cassandra and MySQL and MongoDB and Lucene and whatnot in one application. And the only way to make it work is to understand the APIs, because you can't understand the source code anymore. There's so much of it. And then you design for scale from the beginning. You don't go for scale, but you design for scale. And you automate the deployment and scaling with scripting languages, Puppet, Chef, and so on. How do you make them resilient? Very important to design for failure. Like I mentioned, Netflix has a process called Chaos Monkey that randomly kills applications in their live production environment. And that just serves as a reminder to every developer that they must build software that can withstand that sort of assault. And as they do that, they end up having some of the highest uptimes in all of the US. And Netflix accounts for 10% of internet traffic on Friday evening. So it's a big, big operation. And they have a Chaos Monkey and other chaos things as well. I forget their names. And making applications user-friendly, of course, make user experience a priority. Test on users before you code. It's very possible today. And do A/B testing. We had no possibility to do A/B testing before because we're shipping software to everybody. Today we have cloud services. It's very easy to test concurrently on different audiences, different designs, and see which one works. And you can track how they use the software on a very detailed level and draw real-time conclusions from it and change your user interface and your usability. So that's how you do it. It's fast, lean, and agile. You do it quickly. You lower the cost of failure. That increases innovation, and you apply a new form of software design that we didn't have before. And I didn't go very deep into it. But I'm done now, and it's 7:12, so I'm just 2 minutes after my timetable. And talking about our releases every 50 days. Let me brag a little bit. In our latest release of Eucalyptus, we have warm upgrades. So you can now upgrade the cloud platform without taking down the workloads, which means that your production environment will not even notice that the cloud platform is upgrading itself in the background. I believe we're the absolutely first cloud platform to allow this inside the product on customers around on-premise. So we're very proud of that. If you're interested, you go and download Eucalyptus 3.4 and try it out. Of course, first you need to install a previous version to try the warm upgrade, of course, if that's what you're trying. But trust me, it's there. So let me stop here. There's my Twitter handle and email address if you'd like to reach out to me. So thank you very much. I don't know if we have time for questions or we should move on to the next one, but I'm available for a few more minutes if there are questions from you. Thank you.